So hi, if I ask most of you what this is in my hand, you'd say it's a Pringle. But if you ask a cardiac surgeon, they're going to say it's exact shape of a mitral wall, which is the wall of a heart, and its function is to let the blood flow from the atrium to the ventricle. But if it doesn't function properly, you have one of the most common heart wall diseases called mitral regurgitation. And the gold standard to treat this is by implanting a ring on the wall and attaching an artificial cardia. And this is typically done in a minimally invasive manner using endoscopic support. And this is an extremely challenging and expert-driven surgery. And the surgeons sometimes also use a patient-specific simulator that you can see here for surgical training and planning. The work of my thesis focuses on using the endoscopic images that we get from these two domains and to support this surgery. And I'm going to tell you how. So one task while implanting the ring is that the surgeons need to make sutures on the wall. So what you see here is an actual mitral wall of a patient, and we can build a model to automatically detect these points. And why do we want to do that? Is to use them as augmented reality markers or quantify suturing techniques. And so we also worked on a metric to quantify or evaluate how well a model can track these sutures across two different camera views and the time dimension. So now that we have endoscopic data from both the domains, another task we can define is to make the simulator more realistic. So it appears more realistic if we can translate the images that we see on the simulator to make it look like the real wall. And all of these were performed on a data set that we acquired in Heidelberg University Hospital, and we released it to the MICCAI community in the last couple of years, firstly with point labels and then a bigger data set without the labels. And the second task is to reconstruct the scene in 3D, because it really helps to know quantitative measurements of the wall to make surgical decisions. And previously this was done using infrared sensors, but as part of my PhD we also found a method that works like with a commercially available sensor in close range for this application, and it's ongoing work to completely get rid of the sensor, to just use the endoscopic images to reconstruct the wall so that we can make these measurements. And finally, we, as part of my PhD, also brought all these features together in a tool that we call Smart MVR for surgical measurements in augmented reality that not only helps make these measurements, but also serves as a platform to support the surgery, because then we can integrate the AI models that we're also developing in the future. So with that, I'd like to conclude by thanking my team and all the collaborators, and get in touch if you want to know more.